Hi, this is the second of two factorization videos looking at a whole bunch of examples on factorization. Let's get stuck into it. Okay, this one doesn't look like it has any common factors whatsoever for these two things here. There's no m's in both, there's no numbers in both that are common. So we have to look for a fancy rule here. If we wrote this as m squared minus 4 squared, it'll fit into one of the arrangements called the difference between two squares. When you can have a squared minus b squared, you're allowed to factorize it with a and b in one bracket with a plus in between them, and a and multiplied by a bracket with a minus b in it as well. You'll have one plus and one minus there. I'm sure you've seen that in class before. So if we can write it as write this pair here as m squared minus 4 squared, we could have m plus 4 in one bracket and m minus 4 in the other bracket as our factorized version. If we're careful here, after we look to see if there's anything common between here and realizing that nothing common goes into each of these terms, we could write 9y squared as 3y being all squared, because 3y times 3y is 9y squared. And we could write 49 as something smaller, all squared as well. 7 squared is 49. That allows us to follow that rule again. We can have a bracket with 3y plus 7 and a bracket of 3y minus 7. So it's just a trickier version of the previous rule there, difference of two squares. Here we look at first to see if there's anything common between them, and there is something common between them. We can have 3 out as a common factor. What have we got to multiply 3 by to get 3b squared? Would need a b squared in there. And 3 lots of what makes minus 75? 3 lots of minus 25 makes that. And you think you're done because you have done a factorization here, but we need to factorize fully. And you can notice that we can have 3 out the front, and we can actually write b squared minus 5 squared there. And so we can keep going here. b squared minus 5 squared is a difference of two squares. We're allowed to then write b plus 5, b minus 5 as the factorized version of that. So there's a couple of steps in there. If you spot that, what's left after you do the first factorizing is potentially one of those difference of two squares. Now we have to make a bit of a stretch here, but we can even bash this one into shape and express it as a square root of something. All squared as well. So we can write a squared minus the square root of 6 squared. Do you agree that if you square a square root it'll cancel each other out? So this is actually a fairly complicated expression, but that still has the same value as the 6. And why I'm doing it is because I've then able to follow that rule that says if you've got a difference of two squares, you can have a factorized version of a plus whatever's being squared in the second bit, and a minus whatever's being squared in the second bit. That's a real try-hard question, this one. I mean, it's a bit of a stretch to get it into that arrangement, but it is possible to write it out like that if you wanted to. Alright, now there's some shortcut rules with cubes as well. We can write this as c cubed plus 2 cubed. Now there's a special arrangement of the difference of two cubes here, so let me remind you of that. We're able to then write this as a factorized version of c plus 2, where you just have a bracket with the two numbers there in the bracket there. Then we have another bracket, and we have c squared. We have a minus the product of those two numbers. Now the product of those two terms is going to be 2 and c, plus that last term all squared. So that's the arrangement we've got. The two terms just in their own bracket there. Then the first term gets squared. Then it's the minus the product of the two terms, in this case 2 and c, and then plus the final term squared. So we'll just tidy that up and do that last squaring there, but you get c plus 2 outside of c squared minus 2c plus 4. So the sum of two cubes that rule is. Check that out in your studies or your textbook. You can also have this one, which ends up being the difference of two cubes. We could write 27 as 3 cubed. And when we can write it like that, that can fit into this arrangement. P minus 3 this time. That's just listing the two items, the P and the 3 in one bracket. Then we've got the first term squared plus this time the product of those two terms plus the last term squared. So that's just the arrangement for the difference of two cubes. So look up that shortcut in your textbook and get good at it. That would be good. So once you know these rules, the way they pan out here, shouldn't be too hard to think about. They just follow the same pattern there. So that's a special arrangement for the difference of two cubes. This one doesn't look like a difference of two cubes, but 8 is 2 cubed minus d being cubed. So that could fit into that arrangement whereby we have the difference of two cubes. First of all, we've got a 2 and a d. Then we've got a 2 squared plus these two multiplied together plus the last term squared. So if we wanted to, we could just turn that 2 squared into a 4. And that follows that same arrangement. It just looks a bit weird because the number is first, and that's not usually the case. Alright, now this looks like we could do a sum of two cubes, but 18 isn't anything cubed. 8 is something cubed, but it's got to be in the right arrangement there. If in doubt, our first step is to find anything that's common between them. There's no letters that are common between them, but they're both even numbers. So let's just take 2 out as common and see what we're left with. 2 out of that would be 2 multiplied by what gives you 18f cubed. 9f cubed plus 4g cubed. It looks like it should be one of those sum of two cubes, but for that to happen, the numbers out the front need to be cubic numbers, and 9 and 4 aren't cubic numbers. Looks like they should be, but that's the best we can do there. Okay, on this one, first thing we look for is any numbers or letters that are common to all three terms, and there's, I think, 3 and m can come out as common. What have we got to multiply 3m by to get 3m cubed? I think we need an m squared. We've got to multiply 3m by 5m to get 15m squared, and we'd have to multiply 3m by 6 to get 18m. Now that is certainly a factorising, but if you really have to have a look and see if you can factorise further. And if you just looked at this bracket, that is a quadratic arrangement that we could do PSF on. If we just did PSF on that one bracket, we could look for a product of 6, a sum of 5. I think this was in the previous video, this exact arrangement. The factors of 6, 1 and 6, 2 and 3 looks good. So we could actually factorise more fully there into m plus 2, m plus 3. So when you've factorised once, taken out something as common, see if you can keep going. That's one of the key bits here. Okay, and that's the end of your second factorisation video. I hope all those examples help, one of each type there. And ask your teacher if you're not sure. peterblakemaths.com. Catch you next time. Thanks for listening.